For more problems and videos like this for linear algebra, you can take a look at Sarai Studies, link is in the description box below. In the last video, I showed you the algorithm, the series of steps, the recipe that we use to get any matrix A into row echelon form. That recipe is called Gauss elimination or row reduction. In this video, I'll show you how to get any matrix A in reduced row echelon form of A. And the procedure, the series of steps, the recipe that we use to get any matrix A into reduced row echelon form is called Gauss-Jordan elimination. And the first step in performing Gauss-Jordan elimination is to perform Gauss elimination, aka row reduction, in the first place, because it's in the name. Reduced row echelon form is literally row echelon form, just reduced a little bit more. So you first have to perform the procedure for row echelon form, which is just simply Gauss elimination. And then for the extra little bit of reduction that you're doing, we call that Gauss-Jordan elimination altogether. So this is the same matrix that we started off over here. We got it into row echelon form. So this is what we're going to start off with. So the first step is to get it into row echelon form. It is in row echelon form. Then after that, we start with the last pivot. And the question is, how do we get it to be a 1? So here's my procedure. I want to change something in row 3, right? 1, 2, 3. And I want to use my pivot position, which is also in row 3. And I want that to be a 1. How can I get it to be a 1? If I divide by -1. But we can't really divide in matrices, so we just say, oh, we're going to multiply by its reciprocal, but it's the same thing. So I'm just going to do negative row 3 is going to become my new row 3. So since row 3 is the only thing I changed, these two rows are going to stay the same. And then this row is going to become just the same row, but multiplied by -1. So we're going to have 0, 0, 0, and then this times the -1 is just going to be 1. We kill the entries above that pivot. In other words, make them 0. So if this is our pivot, we're going to kill all of the entries above that pivot, make them 0. This is 0, so that's good. This isn't. So we're going to kill that entry. So here's the way that I say it. I want to kill something in row 1 because this entry is in row 1. I'm going to use my pivot position that is in row 3 to do so. Then I'm just going to add, and whatever's here, I'm going to put right here. And to find out what I actually need to do to make this a 1, I'm going to take these rows, I'm going to write them down in order of rows the way that they are here. So row 1 would be first. And then row 3 is this one. And then I treat it as an equation. I add a plus just like I have here. And then I ask myself, what's my goal? The goal is for this to become 0. So that's my last value. So here's going to be my last value. Then I focus on this column and I ask myself, what can I change in row 3? Because my pattern is to always just be consistent and only use my pivot, change the value of something. So what can I change in row 3? My pivot's always blue. So that when I add this plus this is going to give me 0. Well, I can just make this a -1, right? So that means if I do something to one entry, I have to do to all of them, even though they're all 0. We're going to do negative row 3. So I'm put a negative in here. And when I do a negative here, this just becomes -1. And these are 0, so it doesn't matter. So then you add as you always do. 0 plus 0, that's 0. 2 plus 0, that's 2. 1 plus 0, that's 1, and then 1 minus 1 is 0, just like we wanted it to be. Now, whatever's here is going to go here. In other words, my row 1 is going to be replaced by negative row 3 plus row 1, which is this one. This is my new row 1. So since row 1 is the only thing I changed, then these two rows are going to stay the same, and then the only one that's going to be different is row 1, because that's the one I changed. It's going to go up here. Now, this is my pivot position. I killed all of the entries above that pivot position. They're all 0, so we can move on to the next pivot position. How do I know what's my next? Well, cross out the corresponding column and row, and then you repeat steps 2 and 3 on the submatrix formed by the remaining rows and columns. So that's these remaining rows and columns. In other words, this is like another matrix we're working with. And then step 2 is to start with the last pivot. So then you go back, okay, what was my last pivot? Well, it was this one. So this here was my last pivot. Then you do the same thing again. Then we move on to step 3, which is kill the entries above that pivot. The only entry above it is this one. It's not 0, so I want to kill it. Again, the way that I say this is, okay, I want to kill something in row 1. I want to use my pivot, which is in row 2, to do so. And then I'm going to do plus whatever's here, I'm going to put right there. And then to find out what I actually need to do to satisfy my goal of this being 0, I'm going to write down my rows in order, row 1, row 2. I'm going to do a plus because that's what I'm saying here. And then I ask myself, what's my goal? The goal is for this to become a 0. That's my third one, 1, 2, 3. So I'm going to count 1, 2, 3. This here should be 0. So then I focus on this column and I ask myself, what can I do when I add this plus this to give me 0? Well, what can I do specifically to my row 2 since that's the row that contains my pivot position? Well, I can make this a minus. So then if I want to change the value of one entry, I have to do it to the rest of them, which is why I have to multiply the whole row by a minus. So this becomes minus, and then this just becomes -1. These zeros are irrelevant. So then when you add, this is what we wanted it to be. 1 minus 1 is 0, and then this is 0. And then whatever's here goes here. So this is my new row 1. So in other words, we are replacing our row 1 with negative row 2 plus row 1. That's how we read it. So since the only thing we changed is row 1, we're going to copy these over, and then row 1 becomes what we replaced it with. This is the pivot position that we had. We killed all of the entries above that pivot position. So we're good. Now we move on to the submatrix formed by the remaining rows and columns. So what does that mean? Cross out the row and column that pivot position's in, and then whatever is left is your remaining matrix. Then you go to your previous pivot position, which if you go back, that was this 2 right here. Now we have to make this a 1. So this one we didn't because it was already a 1. So what do we mean by scale the pivot row? Well, if we want to make this a 1, we ideally want to divide row 1 by 2 because then it would just be a 1. But because there's no really division in matrices, it's really multiplying by 1/2 because it's the same thing. So we're scaling that row, the pivot row, the row that contains the pivot, so that this becomes a 1. I'm going to add a little row operation here. We're going to do row 1, and in practice, I just do this. Everybody understands that. You're really multiplying by the reciprocal. So then this here becomes a 1. And then when you divide these by 2, it doesn't matter because they're zeros. Great. Now your pivot position contains a 1. And then you want to kill the entries above that pivot. But there aren't any entries above that pivot. There's nothing. So therefore, you're done. So this here is the reduced row echelon form of this matrix right here. And something that I did want to point out before we go is notice that every time I wanted to change the value, I always changed the row that contained my pivot position, so the blue. I never actually changed the row that the value I wanted to change was in. So notice any changes I made was on the blue, on the row that contains my pivot positions, just to keep things consistent. And that's it for this video. I'll see you in the next.